So in this lesson, we're going to look at the addition of vectors. Now, this sometimes can be a bit of a confusing topic, like it's not really a concept you might have come across before. But I'm just going to try and illustrate it with a real life example, so hopefully it makes a bit more sense. So imagine an archer shooting an arrow at a bullseye outside on a windy day. So this is the archer, this is the bullseye. But the question is, how do you calculate the resultant velocity of the arrow? So what does this really mean? Well, what's going to happen with the arrow is when you shoot it, it's going to have this velocity, it's going to have a velocity from the archer that's going to be moving in this direction. But also, we're going to have velocity coming from the wind, right? That's going to have coming from this direction. So it's not just going to be a velocity in one direction. This thing you need to think about, when it comes to velocity, it's a kind of think about it as a speed with a direction. If there was no wind, if there was no force from this side, then it would fly straight, but obviously it's windy, so we know that this is going to have an effect on what's happened. So if we have a look at this, we just draw it out. How do we work that out? Well, you'll have a vector P, and you'll also have vector Q. So how do we figure out what these are together? Well, it's quite simple actually. You literally just add them together, like so. And this one goes up here. And then the addition of those two vectors is just going to be the line between the two of them, and that just becomes P plus Q. So it's really quite straightforward. It will make more sense when we do a real life example, or like an example with numbers rather than a real life example. So we'll just go on and do that now. So looking at this example, we're told to let AB equal 1, 2, and BC equal 3, minus 1. Okay, then we're asked what is A to C. So what is this distance here? Or what are the components of this vector here even? That might make more sense. It's not the distance, that's the magnitude. What are the components of this vector? What is this vector? Okay, so how are we going to work that out? Well, from before, that we know that the distance of there to there is just the same as adding that vector to that vector. And we already have information about these two vectors, so we can work it out. So we can see that AB, we write a statement here, AB plus BC is equal to AC. Okay, so what happens when we put in the numbers here? So AB is 1, 2, and BC is 3, minus 1. So this becomes, and you just add these, just no tricks here, just add each line by each line. So 2 minus 1 is going to be 3, no, 2 minus 1 is going to be 1, apologies. Okay, so we're saying from our calculations that AC is equal to 4, 1. Right, now we can check this. Does this make any sense? Does this seem like a reasonable thing to have said? Okay, well, because we've got this chart, this graph here, we can actually just have a look. So we take a different color, and then we're going, okay, so the top line represents the X component. So how far is it between A and C? So it's 1, 2, 3, 4. And how far is A from C in the Y direction? Well, it's only 1, okay? So here we have 1 and 4. So from the looks of it, it does make sense. That's exactly what we're doing. I just want to make like a clear example of what's going on. But what about the subtraction of vectors? We're told that P is equal to 2, 4 and Q is equal to 1, 5. And then we're asked, what is P minus Q? Okay, so for this one, it might make it more sense in your head if we re-sketch it. So this line is P, and this line is Q, Okay, so what we're trying to figure out here is P minus Q. So when you think about the direction of the vectors, this line here is still going to be going up, but because you're minusing Q, it's actually going to change direction, so that's going to be down there. So this is the, you can think of the addition of that negative vector. But what does the maths look like? Again, the maths is relatively straightforward. Equal to, and P being 2, 4, and Q being 1, 5. 2 minus 1 is 1, 4 minus 5 is -1. So P minus Q is equal to 1, -1. Now looking at the graph, does this make sense? Well, here this is the line of PQ. It's going along one and down one. Yeah, that looks like it makes sense.